Okay, so there is a lot on this screen just to stop you guys having to wait around while I write stuff up. So I've kind of written three kind of definitions that we can go with for injective, surjective and bijective. They just help us to actually figure out what we are talking about here. And one thing you'll hear me say a lot in this video is our horizontal line test. So what we're actually going to do to figure out what's injective, what's surjective and what's bijective is we're going to start using these horizontal lines across a graph. Okay, so basically what I'm going to be doing is just drawing horizontal lines. You can see it on this first graph here, like this, across a graph to figure out whether or not something is injective or surjective or bijective. So injective, we're defining that as 1-to-1. So whenever f of a equals f of b, then a equals b. So that's how I've written it here. Basically what I'm talking about is if there's two y values, okay, so we know f of a variable is y. Okay, so if there's one y value for one input that's equal to the y value for another input, then that must mean that the two inputs are the same. Okay, so you're not going to get two of the same y values for different x inputs. So when we see this in a horizontal line test, it means that the horizontal line is going to cross the graph maximum one time. Okay, so this first graph here, for every horizontal line you see, I have crossed the graph maximum one time. So let's say that this here is a y value of 3. Okay, there is no other than this x coordinate here of, like, let's say 2. Okay, there is no other x coordinate that will give a y value of 3. So anytime I have an input giving a y value of 3, that input must be 2. So that's what we're talking about when we're saying injective. Okay, so this y value that we get out, this y coordinate that we get out for f of a, if that's the same as some other y coordinate, it must mean that the inputs were the exact same. Okay, so an example of where that wouldn't be the case is in this next one here. Okay, so if I was to draw a horizontal line on this, so let's say the value I've just chosen here is something like -1. Okay, for a y value of -1, for that to be the output, that means that I could have an input here of, let's say, something like -1, or I could have an input of something like 3. Okay, so to have an output of -1 equal to an output of -1, I don't have to have the two inputs being the same. I could have had an input of -1 and an input of 3. So that one there is not injective, whereas this one was. Okay, so maybe let's write that down as we go. So this one was injective, this one wasn't. Okay, and lastly then, you can kind of try and have a look at this one yourself and decide what you think it might be. So as we look through our horizontal lines here, the first horizontal line there that I've drawn looks like, yeah, it might be injective. Okay, it might be injective. And then we draw a line here and we see it crosses that horizontal line 3 times. So that means that it is not injective. Okay, so that's what we're talking about when we're talking about injective. Our horizontal line can only pass through the function maximum one time. If it crosses through it more, that means that that y value could have come about by having more than one x value or x input. Okay, so again, for example, this one, if I had an output of 1 on the y-axis, that might have come about by having an input of -1 for x, an input of 0.5 for x, or an input of 2 for x. Okay, now I'm just making these numbers up as I go. They're not actually relating to any one function. I'm just making them up. Okay, so that is injective. Now let's have a look at surjective. So surjective, you'll hear me kind of say onto, like up here I kind of say 1 to 1 a lot for injective. Surjective is onto. Okay, so that means that for every y coordinate in the codomain, we have an actual output there. So we have something in the range. Okay, so our codomain is given to us, and our codomain can change. So for this one, for example, okay, my codomain might be something like the set of real numbers. Okay, so for the set of real numbers, any horizontal line I draw for within the set of real numbers, so from infinity, minus infinity to infinity, okay, any horizontal line I draw there is going to cross this line at least once. Okay, so they are all crossing the line there at least once. So that means that that is surjective. Okay, now an example of why this might not be the case is in a graph like this, where the codomain is minus infinity to infinity, because a number, let's say like -1 on the y-axis is not in the range. Okay, so it's in the codomain because it's between minus infinity and infinity, so it is in the codomain -1. Okay, but when we draw my horizontal line at -1, we can see it actually was not in the range for this function. So that means that this one is not surjective. Okay, and then here's another one that you can have a look at yourself. So my codomain is from 2 to infinity. So that means that if I draw any horizontal line within 2 to infinity, for it to be surjective, I want it to cross the graph at least once. Okay, so between 2 and infinity, I can draw any line and it crosses the graph at least once. So this graph actually is surjective. Even though it looks very, very similar, okay, it could have been the exact same graph, but the codomains are defined differently. So that's why this one is surjective, because it has a different codomain, whereas this one is not surjective because there's areas within the codomain that are not in the range. Okay, and lastly, we're looking at bijective. So bijective is both injective and surjective. So my horizontal line test for injective is maximum once. For surjective, it's at least once. So bijective has to be that overlap between maximum once and at least once. So that means that it is exactly once. Okay, so it has to be injective and bijective. So every y coordinate has to have maximum 1 x coordinate, but every y coordinate within the codomain has to be used. So the first one, my straight line, okay, we've seen this in both the examples for injective and surjective. That one then must be bijective because it was injective and it was surjective, so it is bijective. Okay, this one we've seen something like it within injective and it is not injective. Okay, so because we can draw a horizontal line here and it crosses through it more than once, that means it's not injective. So straight away it can't be bijective. Okay, likewise this one actually, if it was defined as a codomain from minus infinity to infinity, it also wouldn't be surjective, so it definitely is not bijective. Okay, but we didn't even need to really define the codomain there. Now it would have been defined in a question, but even before I look at the codomain, it wasn't injective, so it could not be bijective. And last one here, so this is an example of one that would, even if the codomain was minus infinity to infinity, it would be surjective. Okay, because every horizontal line I draw would actually end up being, so it doesn't continue on, but if I had continued it on more and more, as it would do for a cubic function, every y coordinate has been used here between minus infinity to infinity if it was to continue forever in both directions. So this is surjective, but it is not injective. Okay, so it's crossing at least once, And now here it is crossing more than once. So that means that while it is still surjective, because it's crossing at least once everywhere, it is not injective. Okay, so it has to be both to be bijective. So this is not bijective.